Recording in progress.
Okay. Okay, perfect. All right, good morning, everyone. I'll get things started here by just welcoming you all to this morning panel. Thank you for making the time today. This is the ICTAS Matter Lab supporting Virginia's advanced materials and manufacturing ecosystem webinar. We have our panelists here today who I'll introduce in a moment. But ICTAS, for those of you who don't know, and I'm sure Matt will tell us a little bit more about it, is the Institute for Critical Technology and Applied Sciences. And yeah, we're going to be learning more about the facilities at Virginia Tech that support our local and not so local manufacturing ecosystem, as well as the higher education research community. So we'll be learning a little bit more about that today. And yeah, thank you all so much for hopping on. Leo, if you'll head to the next slide. I would love to take this opportunity to just plug the Additive Manufacturing and Advanced Materials, or colloquially known AM2 Hub Conference, coming up on September 15th. It'll be from about 9 a.m. to 4 p.m. that day, and will include a fabulous panel session in the morning featuring many well-known faces in the area, including Nancy Hardwick and Vince Hatcher. I think Vince is on this call, as well as a few others from Danville, just to kick off the morning. They'll be discussing their perspective on AM2 market opportunities, and really that'll lead us into the rest of our day discussing challenges, opportunities to AM2 adoption, including how to get the technology into your workplace, and how to get your workforce up to date on that technology. So that's what this day entails. There'll also be an evening reception that we would encourage you to join. And I'm putting the registration link in the chat for those who want to register but just haven't had the opportunity to yet. Yeah, we strongly encourage you to come out and learn more. Part of what we'll be discussing today will also be featured in our advanced materials session on that day, just even more fleshed out. So without further ado, let me introduce our panelists for today's webinar. And thank you, Leo. We have Matt Hull, and Matt, I had to print out all of your titles because you do so much. So that's never a bad thing. Matt is a research professor and director of the Nanoscale Characterization and Fabrication Laboratory and Materials Characterization Laboratory, as well as the associate director for innovation and entrepreneurship, as well as NanoEarth. And I'm sure he'll be telling you more about all of those fabulous titles in a moment. We also have John Green here today. He's the Chief Operating Officer at ITA International, as well as Carrie Hill. He's Director for Nanomaterial and Emerging Contaminant Safety at ITA International. And they'll be sharing a little bit more about the ICTAS labs, as well as ITA International's partnership with those labs. So without further ado, Matt, happy to kick it off over to you if you'll get us started.
All right, thank you, Emma. Can you see my slide there? Okay, it's not the notes or anything okay, very good. And is the audio coming through okay? Yours was kind of cutting out on me a little bit. I don't know if it's my connection.
Oh no.
Okay.
I'm so sorry.
Yours seems to be coming in well.
It's coming in. Okay, very good. Thank you.
Hey Matt, we are seeing like the slides version that could have notes on it. It's not the presentation view, if that's what you're looking for. Just so you
How's
know.
that?
Yeah, go.
Is that better?
That's it.
Very
That's
good.
it.
Thank you. Thank you, guys.
That's perfect.
So Emma, really appreciate the introduction. And it's great to join you all here today with my colleagues from ITA. So I do want to make it clear, I think it's a two-part conversation. So I want to present a little bit here on our ICTAS Matter Labs. Thank you, Emma, for the intro to ICTAS. In the interest of saving my colleagues plenty of time to talk about the exciting work they're doing, I've tried to streamline the presentation a bit. So hopefully I'll throw out some teasers that'll make you want to reach out to me or visit our websites that I throw in here. But I'm going to give you a quick tour. It will not be exhaustive. and I'm happy to follow up with each of you who have any questions following this conversation. Um, I thought it was fortuitous that we had a really nice article in the VT Daily News recently. I think this is just a few days ago, that featured Associate Professor Hong Yu from the Department of Material Science and Engineering here at Virginia Tech, and it was touting his work securing a multi-million-dollar award from the U.S. Army to fund some of his work, where they're looking at new ways to create and repair metal in wartime and beyond. And interestingly enough, Professor Yu is one of the top users. He's actually the top user of our NCFL. And we like to see the success of faculty members, companies, other folks who use our facilities, because that's what we're here to do. We're here to provide instruments and tools and capabilities and expertise that really help our region and individuals working across sectors in our region really advance their research, secure those funds that we need, not only to bring the research here, but to bring jobs here. And so that's a really important part of what we do. And we take a lot of pride in that. The ICTAS Matter Labs, I've sort of renamed it because of the title issue that you were talking about, Emma. I started off taking on the nanoscale characterization and fabrication lab director role. And then ICTAS, building on the success of the NCFL and working with collaborators, for example, in the Materials Innovation Institute or the Macromolecules Innovation Institute, they've added some shared use labs. And I want to try to help you understand the differences in these three labs and how you work with them, because it can get really complicated really quickly. And we don't want that to happen. At the end of the day, we want to be doing things like Professor Yu is doing there. And we want to be just cutting through the red tape, getting you into our facilities, helping you get the data you need, and helping you be very successful at the end of the day. So the first lab I'm going to spend a lot of my time on today is the NCFL, and that's the one my ITA colleagues have really used extensively. And that's a fee-for-service lab. I'll share more about what that means. It's Virginia Tech's, it houses Virginia Tech's most advanced tools for working at the nanoscale. So those are actually atoms, dumbbells that you see there in the image behind there. And those are things that are really only seeable through our NCFL tools. The Tiedemann Materials Characterization Lab and the Biomaterials Characterization Lab are actually free to Virginia Tech personnel, and these are more for routine use for characterization of different types of materials and biomaterials. And while they're free to VT personnel, we have expanded our efforts to make them accessible to industry users through a program called TAP, the Technical Assistance Program, offered through continuing and professional education. And I'll talk a little bit about that. But in short, ICTAS Matter Labs are three labs that provide the tools, training, and expertise that you need to advance the region's materials characterization and fabrication work. Quickly looking at the impact of our Matter Labs, if you look at the purchase orders that are generated through our NCFL, the grants that are used to generate those purchase orders represent about $150 million a year. So we feel that's an important impact, that $150 million a year of Virginia Tech grant dollars use the NCFL in some way, shape, or form. We support major university centers. Many of these centers can't exist unless they have a facility like the NCFL. Groups like the National Nanotechnology Coordinated Infrastructure, the Nano Earth Group, GlycoMIP, the Virginia VAST, the Semiconductor Technologies Group. We have about 300 users per year of the NCFL, nearly 400 for the MCL, and another 60 for the Bio-MCL. Some of these are duplicative because PIs will make use of all of the facilities they have access to, but that represents distinct users of those facilities. The NCFL, through its user fees, recovers about $300,000 a year. That goes back to help offset operating costs, things like service contracts, which can get really pricey. And importantly for this group, about 20% of our users are from small business, and you'll recognize some of these folks on here now. And it's not an exhaustive list, and I would certainly love to add logos on here. And of course, I want to point out my ITA international colleagues there. They are frequent users and expert users. We always love it when Kerry and his team come to visit. I probably bug them a little bit too much because we reminisce about days working together and that sort of thing. But they do great work and make use of these facilities, and we're proud to support our small business partners. Our team is located out in the Corporate Research Center, the NCFL. If you've not visited, please come and see us. The facility was established in 2007, right in the heart of the CRC. I think the ITA folks are located over here in the Founders Building, but we have small businesses all around the park. A lot of you know our team, Steve McCartney. Steve recently retired, but he will be coming back in September on a part-time basis. Dr. Waynon Lang, Jarrett Wright, Dr. Hong Yu Wong, and Suzette. Wonderful team out there supporting our VT researchers and our folks in industry. I don't have a lot of time to go instrument by instrument here for you, and I apologize for that, but I will set up a little teaser here. Over the last 2 years, the NCFL has been transformed. It's the most significant update in our tool set since the facility was established in 2007. And what I'll do is, Emma knows this, we've all been very busy, I think, the past few weeks preparing for that week. What is it, the week of September 15th? There's the Advanced Manufacturing Workshop, and we're running a workshop. This is going to be 3 days. You'll be rotating on 6 tools. You'll be working with our experts, bringing your samples, and we're almost at capacity for registration. So if anyone's been on the fence on that, you might want to go ahead and register, but we will soon have to close it because we are almost at capacity. But the workshop will feature time on each of our advanced tools, things like our new aberration corrected transmission electron microscope, our new correlative Raman SEM instrument. These things are all installed and ready to go. New e-beam lithography tool. So we're really excited about that, really grateful to our sponsors who chipped in to help make this possible. But I don't know that we've done anything quite like this at the NCFL. So if you really want to go into a deep dive on these tools, register and come join us, or contact me if you can't make the workshop, and we'll make sure we get you in there to help you learn more about what we have at the NCFL. To access the tools, if you go to our website, the QR code there will take you to it. There's really 2 action items at the bottom. That's all you really need to care about. The first one will take you to our instruments. There's a clickable list there. You can hit the plus button there on those accordion tabs, and it'll tell you everything you need to know about the tools that we have available. And then to access the NCFL, you'll click the other button there, and we have another set of drop downs. If you start here, that'll start working you through the process. So the first step's get a PO. Second, for our external users and industry, is to submit a work order. And then the last part of that is to create an account in our facility online manager, and you'll be rocking and rolling in no time. So I really like to talk through. I know the access stuff can get a little tedious, but we often hear that folks have a hard time knowing what they need to do to get into our facilities. And we want to cut, like I said, we want to cut through some of those barriers and help you get access much more easily. For the Materials Characterization Lab, and it's recently named after Dr. Tiedemann and a generous donation that he had made to Virginia Tech. This is a joint venture with Virginia Tech's Macromolecules Innovation Institute. And Emma, I noticed in the YouTube channel that you folks had, Professor Bob Moore, who is the director of MII, was speaking on that. So we worked very closely with them. And the MCL was established just before 2020. It's here in Kelly Hall, which is on campus, so not out at the CRC. It's on the 4th floor. It's a shared user facility, about $6.5 million in tools, and it's available free of charge to VTPIs. This is what really makes it attractive to folks. The core facility manager here, the person you'll interface with most initially, at least, is Dr. Ritt Borgeheim. He manages the facility. Connor Farrell is probably who you would be working with the most on using those tools. And Shengyang Tao is another materials characterization specialist working with the MCL, who's really focused on computed tomography and X-ray tools. So that's our team for the MCL. For the Bio MCL, this is a collaboration with Beam here on campus. We just established it earlier this year. It's located on the 3rd floor of Kelly Hall, just below the MCL. And it's a shared user facility for biomaterials. And it really focuses on folks in the biological fields. And again, just like the MCL, it's available no cost to VTPIs. RIT manages that facility as well. Sherrod is our biomaterials characterization specialist, and we encouraged Kathy Lowe to come out of retirement to help us learn how to do biological sample preparation. This is really important if you're going to do imaging of biological tissue at the micron to nano scale. You really need to prep the tissue appropriately. And Kathy has over 30 years of experience doing that. And she's been working with us to really help advance that capability here at Virginia Tech. I don't want to go into a lot of detail on the instruments of the MCL, but basically we have a lot of the routine characterization tools that you would need for polymers, ceramics, metals, all sorts of different types of composites, people who do, again, research in various types of polymeric materials, battery materials. They're frequently, they and their students are frequently using the MCL. For the bio MCL, it's a lot of emphasis on routine characterization of cells, tissue, and other biological materials. And again, a free facility. Folks can come in, register for use, and be off and running. The procedure for accessing the MCL and bio MCL is a little different. If you recall, I mentioned the NCFL is a fee-for-service lab. The MCL and the bio MCL are not. And so the access procedures are a little different. And if you click on that QR code, I think we'll have these available. Talk's going to be on the YouTube channel, right, Emma? And then I'm also happy to share the slides with anyone who needs them. But this will help you. You select the MCL or the bio MCL. If you're a student user versus a faculty user, you may have a different form to use there. And then the form triggers a series of approvals that ultimately result in you getting access. And if you have any trouble there, you can always reach out to me. My email address will be up here in a minute, and we'll make sure that we get you taken care of. And what I mentioned, I really want to make sure that I'm talking to the industry users on the call, because I do understand, I think that's a significant part of our Advanced Materials Consortium. Industry use of ICTAS Matter Labs can span a range of mechanisms, and fee for service is the one we know a lot about. This one's really easy. This is the one that the ITA folks use on a regular basis. You schedule time on an instrument, you have a set hourly rate for what that instrument costs, and then you set up a PO, you pay for the time you use, you get the data. We're not worried about intellectual property, that sorts of things, because we're really not getting into that area. You're looking at your samples, you know what your samples are. It's a very simple and straightforward methodology. It does require a lot of things on our end here at the university. So we have to be set up as a designated university cost center. So there's some things that we work through to make it easy for you to use the facility that way. On the other side of the spectrum, there's sponsored research. And this one is the one when we talk about the university overhead fraction of a project that's allocated for overhead. This entails a lot more collaboration, potentially the development of intellectual property, a much more extensive, usually longer term type of project. And those are sort of at opposite ends of a spectrum that I like to think of when we're working with industry. But in the middle, there are technical assistance projects, and this is an area where we have been having a lot of fun working with industry collaborators. And if you've struggled with the sponsored research side of things or any of the other aspects here, let's talk about how we might be able to do some projects through the technical assistance project program. It does have some very specific requirements that need to be met there, but we have worked through these types of programs with a number of industry collaborators, and it's given us a nice middle ground for some of these projects that don't quite fit fee for service. They're not in the sponsored research domain, and sometimes they require use of a facility that isn't necessarily set up for industry use. So I don't want to spend too much more time talking through that, but I just want you to understand that there are a lot of different types of usage mechanisms, and these will vary based on the Virginia Tech resource that's being used and the nature of the project. It's important that we select the most appropriate mechanism. It can be challenging to do that, but we can help walk you through that. And finally, I think I'm doing okay here on time and want to make sure Carrie has enough time to talk with you. But just the key take homes here, our Matter Labs are set up for you. We really want to help advance Virginia's advanced materials and manufacturing ecosystem. The NCFL is a state-of-the-art facility. It's fee-for-service access, easy access to some of the most advanced characterization tools available for the types of work you're doing. The MCL and BioMCL have diverse characterization tools available. It's free to our Virginia Tech folks, but also available to industry through things like TAP and even sponsored research if we want to go that route. We want to work with you to use, promote, and improve our facility. I like to say our facilities because if you're paying taxes in the state of Virginia, you've paid for some of the equipment and staff time at our facility, and you should take advantage of it. And it can be research. We can do courses, labs, training together. The workshop that we're going to have in September, we're hoping to use as a precursor to do more targeted courses in collaboration with industry and other folks. We want to use this as a tool to recruit faculty to Virginia Tech, but also to help recruit industry to our region and retain those industries. And of course, work more closely with our industry collaborators. There's my email if you need to reach out to me. And with that, I will be quiet and turn it over to my good friend and colleague, Dr. Carrie Hill. Is that okay?
Matt, yes, that's great. We've a question in the chat from Eddie Amos. He's asking, can I attend as an observer from Go Virginia? I assume referencing your event on the 18th, I believe.
Absolutely. Absolutely. Send me an email, Eddie, and we'll get you, we'll register you, but we would love to have you.
All right, Carrie, take it away.
Of course, as soon as I share the screen, it goes bonkers and starts moving things around. I assume you can see the screen. Somebody squawk if you can't. We have done a lot of work, as Matt said, with the ITA or the NCFL and the MCL in particular. So I can share a little bit about some of the work we've done and how we've used it. It's kind of a use case for you guys, so you can kind of see how it's worked for us, and hopefully that kind of spills over into the kind of work that you might want to do with the lab. So as a introduction to who we are. ITA International is a contractor that's defense contractor based in Newport News. We have people all over the world doing work, serving U.S. military and other government ventures around the world. Operational support, including training, logistics, maintenance, and repair. Data analytics has kind of been, this is the kind of the core of ITA's processes. In 2023, they brought us on. We were formerly NanoSafe, who Matt established back in the day, 2007, I think, right? And now they folded us in as part of their endeavor to promote a sustainable human ecosystem. So we have been brought in our materials characterization expertise, brought in our exposure assessment expertise. And as Matt said, we're located right across from the NCFL. Sometimes I'll actually walk over there. In fact, yesterday I walked over there to do some SEM work. So it was a nice day. So we're very conveniently located in our location here in Blacksburg to do work with the NCFL. Some of the work we've gotten into, we have both sponsored research from the federal government and some commercial testing. Our sponsored research has spanned, NIST, CPSC. We have active projects with NIST and NIH right now. Had a decade-long relationship with the U.S. Army ERDIC, doing a lot of work from everything from 3D printer emissions to water contaminants to graphene. We do a lot of commercial work with the Graphene Council and Advanced Carbons Council. We're one of the preferred testing labs for that group. And so we get a lot of work done there where we're commercializing, characterizing graphene and related products. And that's where we get a lot of our work in with the NCFL. The NanoSafe tested process is kind of this procedure in which we can help the stopgap here where we have products and different procedures that may not have an established standard or standard protocol for assessing either exposure or even just materials characterization in itself. And we kind of provide a way to address those issues and address those areas where there are not existing standards and can help provide data for people who are working on innovative products. So the modalities of use, Matt already mentioned the two ways that this facilities can be used. Direct use of the NCFL is possible. We use things like SEM fairly frequently. We're over there a couple times a month at least. Oftentimes, if we have a lot of work going on, we can be over there multiple times in a week to do evaluations. SEM is one of the instruments that we use predominantly. And just, I have lots of great nerdy images, but this one here is always more fun. Back in 2000, you guys remember we had, a pandemic, but also remember the murder hornets, that whole thing that happened. We were visiting some family for the first time as the pandemic was rolling on, and found this guy buzzing around in the house. And so I very bravely and totally without lots of screaming captured him in some Tupperware. And then, a couple months later was at the NCFL to do some imaging on some, very scientific samples, legitimate business. At the same time, decide, you know what, let me stick the murder hornet in there and let's see what we got. It actually turned out to be a European hornet. I talked to somebody at Virginia Tech who's an entomologist, and he assuaged my fears, but he said, don't get stung, it'll still hurt. But this just kind of very well illustrates the amount of detail you can get out of SEM. If you've never done scanning electron microscopy, you'll be amazed the kinds of things you can see. Sample prep is very simple. And you can see here just some images of the murder hornet, or excuse me, European hornet, I guess is what it actually was. The eye of its multifaceted eye, the antenna, which has all kinds of these little cilia or whatever they are coming out that are pretty finely featured. So SEM can go even way more detail than this, but it's a really useful instrument. And in our case, we get to use it directly. I'm trained to use the SEM. Other members here at ITA are trained to use various SEMs, and so we can go in and actually investigate our samples directly. We don't need to have any help, and that's helpful in some ways, as Matt already mentioned. With if we have sensitive IP, we don't necessarily want to be sharing details about some of the materials we're working with because of federal restrictions, or even because of commercial restrictions. If we're working with a certain company who may not want that information known, it's just us seeing it. They don't have to see it. And so that works out really well. And then we can, use the equipment ourselves and get trained really well by guys like Steve and Wayne on. Other modalities would be indirect use. So we also will submit samples to Waynon, for instance, or over to RIT to get the samples analyzed. So Raman spectroscopy is one of the methods that we use, on a very routine basis, monthly at least, to analyze different kinds of carbons that we get samples of. And that's one where we send the sample, drop it off, Waynon picks it up, and he does the work for us. And that's really handy as well. So that's another modality we often use. I'm going to spend most of the rest of the time going through some case studies because I think that will help illustrate in a more direct way how we're using it, and hopefully and illustrate a little bit better. Feel free. I'm going to go through this fairly quickly so I have time to wrap up for questions and everything, but I'll spend the next 20 minutes or so going through these case studies. If anything pops up and you want to hear more, please shoot me a note. My contact info is going to be at the end. Emma can get it to you. Matt can get it to you. Would love to talk about this more, whether, we can help you understand how you might be able to use the facilities, or if we can do the work ourselves for you, we're happy to do that as well. We do that for lots of people, where you say what you need and we go figure it out for you and interface with these folks and do all that complicated PO business Matt was saying. It's actually not that bad. It's pretty easy to get set up, but we're happy to help. So anyways, we've used the Matter Labs for the NCFL particularly, and the MCL as well, for both federal R&D for sponsored projects, as well as commercial projects. So I'm going to go through a few case studies. The first case study, what we are using the NCFL quite a lot for, probably, more than half of our work right now, is through work where we are characterizing graphene. As I mentioned, we do a lot of work with the Graphene Council. The Graphene Council has established this graphene characterization framework, classification framework, which just became an ISO standard, by the way, and we were involved in helping to kind of specify that. And that's going to be released as an ISO standard. I believe it just was, maybe even last month. It's been on that final ballot. And those of you who have been involved in ISOs know how that kind of works. It takes a while to get the final balloting working, but I believe it's just been released. And it's a 19-point characterization framework, which includes things like the layer counts, thickness, lateral size, chemical composition, all of that stuff, surface charge. All those things are measured almost entirely. This is done in the NCFL on our end. We prepare the samples in our lab. We do a few of the measurements here, but on this particular kind of work, we are very reliant on what the NCFL offers for us to conduct this business. It's a really important facility. It would take us, we'd have to scale up our business in this area by 10, 20 fold to even justify buying one of the instruments that the NCFL provides. And so we're really grateful for that support that's available to us. So we go through, we get our sample, and in a matter of, a week or two, if things go well, we can have all of the data we need to fulfill this technical data sheet that we produce for the Graphene Council and ultimately the customer of the Graphene Council, who are these businesses, oftentimes startups, sometimes some established companies who are making graphene, and they want to make sure that they have a technical data sheet that they can show off what they're making, and so the end users know what they're getting, and know how to use their material effectively. So these next few slides, it's kind of a screenshots of the technical data sheet, and you'll see here, I'm not expecting you to be able to see everything on these pages, but here's an example of one we did 2 years ago, of a powder that was a few layer. You look at it and it just looks kind of like fluffy black powder. And how do we describe that more fully? Well, we go to the NCFL. So we do Raman, we do XRD, we do TEM, we do SEM, we do all these things, and we end up with Raman spectra, which if you're a Raman spectroscopist or spectrometrist, I guess, and you're familiar with graphene, you'll recognize the D and 2D and G peaks that are characteristic of graphene and graphite. We do our XPS, and we provide, use that information to provide the actual breakdown. In this case, this graphene had some additives in order to keep it from restacking, and so that's where some of these extra impurities come from. We make sure we note those. Later in the TDS, we have other things. We have a representative TEM and SEM image, XRD, TGA. We have a bunch of images after that of the actual graphene. So here's a graphene powder with SEM images here on the left. And we provide them with 20, 30 images so they really can see what their material is. You'd be surprised. Some companies are making material and they think they're making graphene. They've told everyone around them they're making graphene. They give us a sample and we're like, either no, you're not making graphene, or yes, you are, but you're also making a lot of other stuff and it's all in the same place and you need to separate it. And so we kind of help provide that feedback to them to allow them to improve their product. That's really important to us. So this is an example of a pretty nice, ended up being few layer graphene, 1 to 4 layers, essentially. Most of the particles were below that. You can see here, if you have these TEM images, you can zoom in and we actually physically count the layers there. We can use other methods through XRD to automate some of that, but we always go in with TEM and do some random sampling and then actually measure and count the layers that are present in the sample, up to 20 flakes is what the standard calls for. And this is really interesting. If you're someone who has been involved with graphene at any point, you're probably thinking of thin film graphene, maybe cast onto silicon chips or whatever, but there actually is a family of graphene that is emerging. Lots of different morphologies that fall far beyond that thin film variety that was first isolated. So most of what we work with are powders that are used for additives in composites or even lubricants. There are some battery applications, some electronic applications that are being used with the powder graphene, but a lot of this kind of bulk graphene that's being produced now is of a bunch of different varieties and morphologies. So we'll get these samples. They all look like black powders by the eye, and they'll look very different under the scopes and under the other characterization equipment that we're using at the NCFL and MCL. So in this case, here we have all these powders look generally the same by the eye, but we have, few layer graphene, we can have graphene oxide, shell and turbostratic graphenes, which are really interesting because these two varieties of graphene and graphene oxide look very much like carbon black. And so there are a lot of applications where they be applicable and used for those purposes, but they have different surface energies. They have different interactions with composites and polymers. And so it's really important to be able to fully characterize them and describe the structures, describe the chemistries that are involved here. And so some of the traditional techniques they may use in QC in a manufacturing facility just don't fly. So we've got to be able to identify these more particularly. And this shell graphene is really interesting because it really is, you can see in this TM image here in the bottom, this bottom middle of this thing. It's 5 to 6 layers and it's hollow inside. It's really kind of a fascinating morphology. Anyways, I could go on. I'm gonna keep going and stop talking about the graphene. It's really fun. We also, as I mentioned, the quality control is important. We have lots of companies who are working on new stuff. They're trying to tune their process. They don't necessarily have this kind of equipment in-house, especially startups. And they may not be conveniently located across from an NCFL like we are. And so we will work with these companies and, if you just submit a sample to a contract lab, they'll take your sample, you'll get a form letter back with the data, and then they'll say, good luck. If you want any more interaction, pay us X amount of dollars. we don't work that way. We like to take we go to the NCFL all the time anyway. So if we have additional analysis we need to do, we always work with our customers to make sure that we've got that going for them. And in many cases, what we can do is improve their product. So in one case on the left, we had a company who believed they were making graphene. Their investors thought they were making graphene, and then they gave us a sample. They were hoping to get certified as a graphene producer through the Graphene Council's verified graphene producer process, which includes a big, in large part, this analysis that I've just been describing to you. It turns out they were making amorphous carbon, and they freaked out reasonably. Fortunately, it turns out it was a bad batch. They had some tuning parameters that went askew during the last batch they had made. Us looking at it helped them to fix that, and then they sent us another batch later, and it was what they hoped it had been. So really important ways to make sure we can do quality control for people. And then in the other case here, we had another group that was making using graphite to make exfoliated graphite into graphene or few layer graphene. And the first stuff they sent us again was basically just pretty thin graphite. It was not technically graphene. And so similar kind of circumstance, they said, oh no, that's not good. Let's tune our parameters. They did, and they ended up with few layer graphene in the end. So ways that we can work with customers and help them improve their product before stuff hits the fan with investors or customers. Really important. And it's easy to do through this interaction with the NCFL. So another case study is this related is validation of graphene in products. Basically, I'll summarize all this text here. We have customers in the Graphene Council who are making gloves, cut-resistant gloves that use graphene, and they use the name, I won't say trade names because I probably shouldn't, but they'll have a very graphene-y kind of name to imply that they're using graphene. We found that we've actually done, since this study that was done that was published last year, we've done a few more gloves. I think we're up to 8 gloves total now that we've tested through this collaboration. Only 1 out of the 8 has actually demonstrably had evidence of graphene in it. Now, it's really hard to prove a negative, and we try to be very careful about that, to say that we have not found evidence of graphene. Here's all we've done. We try to be very transparent about the work we've done to show that we are really doing the best we can. The one sample that did have graphene, you couldn't miss it. We're walking in microscopy, you can't go 3 micrometers without tripping over graphene. Like, it was there. It was very obvious. The rest, we have not found any evidence. If you're interested, you can check out the paper there at the bottom, and there's much more detail. But it also jives with other studies where it's been found that another group did work where they took 34 different samples of graphene oxide and found that only 4 of those 34 items actually were graphene oxide, essentially. So there's an issue with market integrity. And of course, it really kind of, the Graphene Council is interested because when people get products that aren't actually graphene, but they're labeled as graphene, they don't work, they assume graphene doesn't work. And it's not the graphene, it's the quality of the product. So this is where we are. I'll try to move a little bit faster because I'm talking too much as usual. But what was essentially what we found, for example, was that we had some gloves that did contain a graphitic additive. And so there was graphite in the product, but not graphene. And so we dissolved the fibers, we dissolved the gloves, as well as looking at the gloves themselves in their as received form, and found evidence of graphite in some gloves. In most gloves, we found no graphenic or graphitic material. They used traditional cut resistant additives like silica or titania or steel fiber, which is fine. Just don't say you're using graphene. And the other sample, which had graphene oxide, if you know the Raman spectra, you'll recognize this as a characteristic graphene oxide peak, and we could see the flakes even on the surface protruding from some of the fibers. So we were not doing a performance evaluation. We were not evaluating cut resistance, but what we were trying to evaluate is whether or not there was graphene as claimed for market integrity purposes. And that's what we did. So again, slides, if they're released, you can check out that publication, or if you just Google it and look up our name, you'll probably find it. So an important work we're trying to do to help these folks make sure they have market integrity. Another brief study. This was more federally sponsored research with 3D printer emissions. We love 3D printers. We have several running. There's probably one running in the lab adjacent to me right now that we're using to make some kind of part for some of the work we're doing. But people often don't think about the emissions that are coming out. And things like I see Larry, the meld process, We don't know yet. It might probably is less, and what Hong Yu was working on, it might be less than traditional methods. And so this is something we can do where advanced manufacturing is changing the landscape of traditional extrusion, traditional forging processes that may or may not have worse emissions. The traditional processes, these newer methods may be able to reduce some of the exposures. And so we're interested in eventually working to measure those things. So important stuff happening there. We've been working mostly with your standard desktop printers, FDM or FFF, depending on which modality, but the basically plastic extrusions. We've been working a lot with those and characterize the emissions. So our process was, we work in our clean room. We have our chamber, which is spec'd to this ANSI CAN UL 2904 method, and we can measure the emissions in real time using the equipment we have in our own clean room. And then we capture particles and we take them to the NCFL and we can image them and see their morphology and see other agglomerative characteristics, et cetera. One of the interesting parts of the study was to actually take cross sections. So these images are all of the 3D printer filament that we just cut it, partially polished it, cleaved it, and then partially polished it so that you can see. Intentionally did not polish it all the way, so we can see how the cleaved areas, in some cases, especially where we had the carbonaceous nanomaterials, that was important to be able to see the carbon nanotubes and that kind of thing. The polishing kind of removed our ability. Polishing worked great for seeing these metallic particles, et cetera, but it was harder to see those. And so these are all in backscatter, at least these top ones are. And so you can see the lighter colorations, the speckle pattern, those are metals. Those are materials of a higher Z number, so they show up brighter. They have more backscatter interaction. So we're able to use a technique to immediately see where we have difference in materials. So these really are this magnetic iron, this steel filament. These really did have steel particles. Copper really had particles. Titanium dioxide, which was made by our collaborators in U.S. Army, had titanium dioxide. The other part we could do is do in situ in the SEM is EDS, which allows us to do elemental characterization in the same image. So this image here in the bottom left corresponds to that image just above it, the copper, and you can see with the EDS what elements map to which. And we also found that we had silicon carbide contamination from our sandpaper. So we had to switch to a diamond lapping film to avoid that. So sometimes you find new things that you didn't expect, and that's what's really handy about these instruments. The emissions themselves, the profiles that we would see, very high emissions for reference. Once you get into like tens of micrograms per cubic meter, you're starting to get to where you're hitting thresholds depending on the material. Some of the 3D printer emissions from PETG and ABS at higher temperatures which were within the extrusion specs were up to, over 1,000 micrograms per cubic meter. So a real hazard here if it's not filtered. It's easy to mitigate filtration, ventilation. So we always tell people it doesn't mean stop 3D printing. It just means make sure you're mitigating it. But what's interesting, that's the work we did in-house with our instruments that we have in our clean room. But we also did some analysis of the morphology of the particles that we captured onto to membranes. And so we'd see these spheroidal morphologies, PETG, ABS, these big old clumps of material. Nylon was alarming because it had these little shards, these little fairly high aspect ratio. It was about 60 by 600 nanometers in form. Which, asbestiform or CNT-like, which we know have health effects. So we're exploring this more, but these kinds of things we wouldn't know from our own instrumentation in-house, as much as they are, as great as they are to be able to measure concentration, we would not know this without actually, doing the analysis at the NCFL. So really helpful. And then we also we also saw things like possible free carbon nanotubes coming from the filaments in the air during printing, graphene, that kind of thing, which we were able to validate using those methods. I'm gonna try to wrap up here quickly. We also have done exposure assessments where during the pandemic, there's all of these kinds of new face mask products being produced. Some with this one here had nanosilver. This next image, we had graphene. So all these face masks be antimicrobial. The concern from FDA, and then in the case of the graphene mask, Health Canada, so kind of the corresponding authority in Canada, were not permitting import of some of these masks because they didn't know if they were going to expose the user to graphene or nanosilver. And so in order to get approval, they needed the testing. So companies came to us, we performed testing to assess the exposure potential. In both these cases, it was good news for the companies. The data were going to be the data. We were going to give them the data, whatever it was. If it was bad news for them, that's agnostic to us. But in this case, it was favorable. They're well below regulatory limits. We did not see, in the case of graphene, any evidence of release. In the case of nanosilver, very, very, very small amounts that were orders of magnitude below the exposure limits. And so these mass products were approved for use, and they were allowed to sell in the U.S. And of course, it's kind of tapered off now. The pandemic's ended, thankfully, but they enjoyed a little bit of time to commercialize that venture. Last case study before I stop talking. We did some exposure assessment in a facility. There was a facility that came to us a year or two ago that is working with carbon nanotubes in polymer composites, and they've literally initially were these big polymer extruders, and they were cutting open bags of carbon nanotubes and dumping them in the hopper, is basically how it was described to me. And the workers were reasonably saying, hey, you know what? We've heard this is probably not good for us. Should we be doing something different? And this company's credit, they came to us and asked for help to assess this. And unfortunately, they had already spent most of their budget working with standard testing labs who were using outdated methods to do the measurements, and they weren't happy with them because they were not getting specific enough measurements. And so they asked us to do some assessments. I was able to get them to kick in a little extra to do some of this characterization. They gave us some dust from different parts of the facility, from near the extruders, from down all the way down the hall, and some of the engineering offices that were separated by several doors and lengths of hallway. And we found carbon nanotubes everywhere. We found them in the dust next to the guy's coffee cup in his office. This image here is from closer to the extruders. It's a little more dramatic. But with the SEM, you can see in this image on the left, these longer fibers are carbon fibers. There's some microplastic dust, and then you have this kind of grayish, light gray background. It turns out if you zoom in, these were all carbon nanotubes. So you can see them kind of entangled in this image. And then also we did Raman spectroscopy to verify these characteristic peaks of that. So this company took it seriously. They did a lot of cleanup efforts. They closed the facility down for days and actually basically had a company come in and really clean out everything, clean every surface. And they integrated some like enclosed areas, built a huge gantry system above the hoppers so that everything's enclosed, and they have air wash stations, all kinds of stuff. They took our advice seriously and took care of it, and then were able to reduce that exposure way down below detectable levels based on the quantitative methods that are available. More work to do here, but interesting study. And with that, I can stop lecturing, and we'll welcome questions to me or Matt or whomever. If there are any.
Yeah, Carrie, this is Vince Hatcher. I really appreciate you sharing those case studies. It does help connect the dots. And
Good.
our company was very much involved in making a lot of medical materials during the pandemic, including materials for N95 masks. And we've certainly researched some options to do things like you were describing there with other materials. But just knowing that type of work can be done in conjunction with the Virginia Tech labs is very interesting to us. And so thank you for sharing that.
Excellent. While others are collecting their thoughts on that note, Vince, and to anyone who's interested, we have some other work we were doing that I've not included in these slides because we don't typically use the NCFL as much for it. But the pandemic taught us, and we have a paper published on this in ACS Nano Letters, taught us that the N95 masks are not necessarily as effective as advertised. And because of the way the material is tested, the masks are sealed to the substrate. They use a high flow rate, about 4 times that which a person is usually breathing at during, kind of light activity. And so a lot of these masks that were made during the pandemic, the Shima mask, which is one that the football coaches and basketball coaches were using, those are not able to pass N95, but they actually provide better filtration efficiency on the wearer because they're more breathable. So we have an active program with NIST right now. We're developing a new method for assessing face mask products. That's actually, we have these, you can see half of a head above my head was one of our early forms as we're messing with these realistic head forms to measure how a face mask actually performs on your body. So there's work there that we're doing here that's related to that kind of stuff. We can assess the filtration efficiency in-house in our clean room. And then when we have weird things happen, we'll capture some particles, take over the NCFL and see what's going on. Yeah, it's really important to be able to do that stuff easily. And we're grateful for the NCFL allowing that. It's once you're set up, it's so simple to get over there. And sometimes even the same day I can pop over if there's availability. So it's good stuff. But
Yeah, again, thanks for sharing that. That's our specialty, is creating materials that do the filtration at a lower pressure drop.
Excellent.
And large facilities, HVAC units, data centers, our specialty is doing that high efficiency filtration with lower pressure drop, which directly correlates to lower energy costs, or if you're a medical person, lower energy to pull the air through the mask. So
Yeah.
we're
Fatigue.
involved in all those things. So I can see us talking at some point here soon.
That'd be great. We've got some other ideas we're spinning up that we'd love to chat about that may be more applicable to you. So Vince, we should chat. That'd be great.
Yeah, I'm glad to see connections being formed on the call. That's pretty amazing. And yes, I will absolutely share slides and recording and contact information after the call. But yeah, were there any other questions today?
Well, Emma, can I just underline, John Provo here, joined a little late, but yeah, the connections are great. We've got a lot of great opportunities that I think were mentioned earlier to make more connections. So I hope if you can't make it to Matt's event at the end of the week, you'll at least duck in for our event at the beginning of the week. Matt and this panel will repeat a little bit, but we'll put a new spin on some things, I bet. But we've got definitely some great opportunities to connect, and look forward to seeing some folks with us next month.
Yeah, absolutely. I believe I dropped the registration link in the chat, but if anyone has any questions, I can send out my contact information as well in that email. Yeah, please let me know. It'll be a big manufacturing week extravaganza. So well, yeah, there's, as we like to say, there's no wrong door. So feel free to ask. Okay. All right. I'm not seeing any other questions. Someone feel free to stop me if I'm wrong. But yeah, just wanted to thank our panelists today for sharing more about the ICTAS Matter Labs and also some great case studies of how, that resource has been used by industry and also just the research community generally. Hope y'all found it informative and will maybe encourage you to use that resource in the future. Yep, as I said, recording and slides will be available. And yeah, we'd encourage you to attend the events on the week of the 15th. So yeah, with that, I'll say thank you and have a wonderful day. Great day, everyone. Bye.
Thank you. Bye-bye.
All right, Leo, let's stop the recording.
Are you going to do that on your end or our?
I thought, oh, wait, here we go. We're
Let's
learning
see.
so much. I think it's on your end, actually.
I think you should be good.
Oh, technology.
Yeah. And it should also save automatically at the end of this as well.
All right. Okay.